All right. A couple of years ago, the FCC published a new memorandum regarding RF exposure for FCC authorized transmitters, and those rules went into effect May 3rd, 2021. Basically, they determined a new criteria for determining whether or not transmitters conform to the FCC's expectations of of power density. These new rules applied to all facilities that were authorized by the FCC. That that included all licensed as well as unlicensed transmitters. This was a significant deviation from what has been the case for the last 20 years. The FCC had exempted fixed point-to-point microwave transmitters because their transmitting power density was significantly lower than most other transmitters. The the FCC decided that by May 3rd of this year, everyone had to have determined whether or not their transmitters complied with the FCC's recommendations, and that included both licensed and unlicensed transmitters. The question is, of course, are you as a person who who is who is in charge of an FCC authorized transmitter, were you aware of these rules? Or were you aware that by May 3rd you had to do an evaluation? Did you know that? And are you in fact in compliance? That's a significant question. The last report and order by the FCC indicated that there were two methods of complying with the FCC's rules. You could qualify as an exempt transmitter. If you weren't exempt, then you had to do an evaluation. To determine if you were exempt, you had to do a calculation to confirm that you were below a particular power level. The exemption would require, of course, that you know something about the station and the surrounding areas, because basically you were doing an evaluation to determine if your transmit power density exceeded the FCC's limits for the worst case unexpected user near the transmitter. That evaluation had to be done within 2 years of May 3rd, 2021. Now, the limit of interest was 1 milliwatt per square centimeter. You were trying to determine, did a transmitter that you were authorized to manage, was that transmitter transmitting power such that the power density was greater than 1 milliwatt per square centimeter? That was the general population uncontrolled exposure limit that you were concerned about. If your power exceeded that power density, then there were various actions that you needed to take. Now, if your transmitter was at or less than 1 milliwatt per square centimeter, there really wasn't much that you had to do. You might want to inform the public that they were in the presence of a radio transmitter, but you weren't required to do that. If the transmitter power density that might be imposed on a person near that transmitter was greater than 1 milliwatt per square centimeter, then you did need to take some action. If that power density was between 1 and 5 milliwatts per square centimeter, you at least had to notify the person that they were in the presence of a power RF power density that was higher than the FCC's limits. If you were greater than 5 milliwatts per square centimeter, then you had had to impose additional signage and perhaps perform some method of controlling that person's actions near that transmitter. Well, a Category 1 transmitter was a transmitter that was within 1 milliwatt per square centimeter power density, and very little action was required in that situation. As the occasional user might be exposed to higher power densities, you might be in a Category 2, 3, or 4 condition, and various conditions were imposed by the FCC in that situation, both from a control and a signage perspective. The signs that you would expect to be used in these conditions are shown here. The title, background color, advisory symbols are mandatory, as well as the information that has to be supplied. Sometimes you may be required to provide multiple signs to provide this information and signage. The RF transmitter operator is expected to evaluate its power density and to provide protection to the public in case they might be exposed to higher than FCC allocated power density. That safety includes protections and signage. It also includes keeping the public away from that area if in fact that might be appropriate. Now the fixed wireless communications coalition was concerned about these power requirement evaluations, and they were concerned in that there were over 400,000 licensed transmitters that needed to be evaluated by May 3rd. That was a significant number of evaluations that needed to occur, and the FCC imposed that on the authorized transmitters without any additional motivation other than you just needed to get it done by May 3rd. So what do you do if you don't have time to evaluate 400,000 transmitters? I mean, this is just an additional requirement that you have to take care of, and in your spare time over the last couple of years. There was an additional complication in that there was no adequate method for demonstrating compliance. The FCC's Bulletin 65 only addressed parabolic or circular antennas. The IEEE standard gave inconsistent guidance, and there was no guidance whatsoever on square antennas. Now, square antennas aren't used in the licensed bands, but they are used in unlicensed bands fairly often. In fact, that's probably the most typical utilization of unlicensed antennas. So the Fixed Wireless Communications Coalition took it upon themselves to develop the procedures for evaluating the FCC requirements. And in addition, they evaluated all currently licensed Part 101 transmitters. Of course, this left the issue of unlicensed transmitters unaddressed. I mean, there's no way to really our priority worry about that since we don't know where those unlicensed transmitters are. Now, the Fixed Wireless Communications Coalition came up with these procedures. This is the methodology of evaluating RF power density based on the FCC's requirements. Now, all of these, we did this evaluation on all of the Part 101 licensed transmitters based on the information on the licensees that was supplied by ComSearch, and we did this entire evaluation based on the total transmit power that was supplied to each of the antennas. Now, for those of you who would like to replicate this evaluation, all of this information is available from Seth Williams. If you will contact him, he will be happy to send you all of the slides and all of the spreadsheets that I just mentioned. And you can go through that evaluation yourself and confirm that that the transmitters that you're managing can in fact can be in compliance with the FCC's requirements. If you're a Part 101 transmitter user, then you can feel fairly confident based on our evaluation that you're in compliance, but I'll talk about that in a second. We evaluated, we created procedures for both circular antennas and square antennas. Now here we're showing the patterns for the far field patterns for square and circular antennas. Typically for circular antennas, they're about 50 to 55% illumination efficiency. For square antennas in licensed bands, they're typically 100% efficient. Our evaluation methodology went through 3 steps. The first step was simply to evaluate bore site near field power density. In this case, we were able to clear 321,000 of the Part 101 transmitters. Basically 80% of the Part 101 transmitters cleared this evaluation. That meant that in worst case, no matter where a user was near the transmit antenna, they would be in compliance with a 1 milliwatt per square centimeter power requirement. However, to do that, you needed some information: antenna diameter, antenna gain, composite power. And here's the important thing: composite power meant all power delivered to the antenna on all polarizations, not just a single transmitter. We would, from the antenna information, derive the antenna illumination efficiency, calculate worst case bore site power, and if that power was less than 1 milliwatt per square centimeter, you were done. Most of the cases were in that situation. The next thing we did was said, okay, if your bore site power density exceeded 1 milliwatt per square centimeter, you realize that, of course, virtually all transmitters, all licensed transmitters are designed such that no one can be in front of the transmitter. I mean, if you're in front of the transmitter, you're going to block the power, and obviously the path is not going to work properly. Part 101 paths are designed for very high availability, so we always design them in such a way that a person will not normally be in front of the antenna. Well, for a Part 101 antenna, if you are at the edge of the antenna, the near site power density is never more than 10 dB down from bore site. So usually in this case, if you're sure that you have managed to keep people into the side of the antenna, not in front of it, then the worst case power density they would be exposed to would be 10 dB down from bore site. In this case, we cleared virtually all of the other transmitters. We cleared another 79,000 transmitters, because if you are sure that no one is in front of that antenna, worst case they never approach the antenna except from the side, then the power density is at least 10 dB down from bore site. That cleared virtually all of the transmitters that we were dealing with in Part 101. Of course, to agree to that evaluation, you must confirm that no casual person is in front of the antenna. You usually do this by placing the antenna above the normal population or controlling access to the antenna. At any rate, for the Part 101 cases, this cleared 99.9% of the licensed cases. There still were a few cases where even the edge of the antenna exceeded the FCC's requirement of 1 milliwatt per square centimeter. In that case, we had to do some additional evaluation. In that case, we had to figure out where the transmit antenna was, where the worst case casual person could be, determine that distance, which from the FCC perspective is called a distance of R, and do some evaluations. Now this required some additional information. We had to get to figure out what the worst case distance between the antenna and the person would be. We had to also evaluate antenna rejection relative to bore site. And one of the interesting aspects of that is we might have to evaluate a near field correction factor. Near field correction factor is something that Tom Willis of AT&T Labs and I came up with regard to our activities on the Wind Forum for other cases. But at any rate, that is an interesting correction aspect that you have to apply that we don't normally get involved with antenna power density calculations. However, it was required. But at any rate, you can go through this procedure if necessary. It's significantly more complicated than the steps 1 or step 2 because it does require that you understand where the antenna is, where the worst case person could be, and do an evaluation based on the characteristics of the antenna and the transmitters. But again, we're dealing with the total power that is imposed on the antenna. So the results, based on our evaluation of all currently licensed Part 101 antennas, is that all of them meet the FCC's requirement with one exception. Now, you need to realize that in some cases, the bore site power may exceed 1 milliwatt per square centimeter, and the commission believes that if the bore site power exceeds 1 milliwatt per square centimeter, special signage requirement is required. I'm not sure that I agree with that based on the verbiage of the rules, but I will leave that to the legal experts. We did an evaluation of all the Part 101 transmitters, and excuse me, and only in one case did the site with transmitters exceed the FCC's requirements. That was a site in the U.S. Virgin Islands, St. Croix, and I will leave it to that user to take care of that situation. But basically, for Part 101 transmitters, we had an extremely low failure rate. Virtually every transmitter in its currently licensed as Part 101 passed the FCC's requirements. You can, in fact, do an evaluation for yourself to confirm compliance with the FCC's requirements. And the evaluation is fairly straightforward. If you have the procedures, and Seth will be happy to provide you those, then you can do your own evaluation. You have no reason not to, and you can just get that done, and you can show that you are yourself in compliance with the FCC's requirements. Seth can provide you with that information, or I can provide you with that information. Okay, Joe, do we have any questions on this subject?
I think we're going to have a bunch, and this is great overview about the standard non-complex environment where there's fixed wireless Part 101 licensed. And this is great guidance for a lot of folks out there who are operators who have those situations where they're standing alone and they're not in that complex environment. And here we have a criteria that George has done a ton of work on to walk people through that. And if you can stand by, George, we're going to have two other presenters on some related issues on RF standards internationally and also domestically that are new and what they mean to the overall environment. And also, we'll have a quick overview on the changes in the law that are either occurring right now or are potentially pending, and we'll go through that as well. So high level, we'll first go to Theodora Scarato at the Environmental Health Trust. If you're able to click through your deck, Theodora. And
yeah, can you hear me?
Yeah.
Okay,
Can
great.
everyone hear Theodora?
As Joe said, I was thankful to be part of the EMF Medical Conference. There were continuing education credits provided for medical doctors. There was a conference in 2019 in person and then virtually in 2021. And there were presentations by scientists, medical doctors, engineers, as well as policy experts and practitioners related to the health effects associated with electromagnetic fields, non-ionizing electromagnetic fields. So very briefly, and this is an area that we have a database of many more details of policy issues internationally, but the limits of the FCC, as well as ICNIRP, the International Commission for Non-Ionizing Radiation Protection, are used by many, many countries. However, there are several countries that have a more stringent threshold. So for example, India dropped their limits by 1/10 of what they were before after a review of wildlife issues, impacts to birds, bees, and trees. They also, China and Italy and Switzerland have more stringent limits, especially for areas where people sleep or schools. So for example, Switzerland actually uses the ICNIRP limit, but then when it comes to certain situations, a more stringent limit. Some countries have these limits because they've adopted the precautionary principle. So they will drop down a certain factor because in recognition that there are science indicating effects at lower levels. Some countries, and that's precautionary, some countries like China and Russia consider that their limits are biologically based. So they recognize that biological effects could exist, and then they've come up with a threshold. Now, of course, it's a whole different conversation as to the limits and the safety of those limits because of the growing body of science. But we ended up filing against the FCC along with several other petitioners when they made their 2019 determination that the FCC limits that were set in 1996 were adequate. There were several years of a substantial docket had occurred of evidence, just hundreds of studies and many different recommendations related to many different issues. Long-term exposure, children's vulnerability, people that testified they'd been injured, impacts, non-cancer impacts, impacts to the brain and reproduction, as well as impacts to trees, birds, bees, environmental impacts. And also the issue of the way that RF compliance is done for devices and for macro antennas and so forth. So the DC Circuit ruled in 2021 that it was an arbitrary and capricious in relation to the issues of long-term exposure, children's vulnerability, non-cancer impacts, environmental impacts. And the FCC was ordered to address why it made that decision. And we don't have a response at this time, and we await a response from the FCC. The FCC was ordered to address those issues in 2021. I talked about how India lowered its limits to 1/10 of ICNIRP because of the interministerial report. So now I want to briefly talk about some policy issues. Many countries have government programs measuring cell tower network radiation levels, environmental levels. They are publicly posted in a very accessible way to the public: France, Greece, Turkey, Switzerland, India, Israel, United Kingdom, Australia, and it goes on. You can see the slide there, but I'm going to give you some examples of some things. So, oh, thank you for following me with the slides, because I'm just moving ahead. We know that levels are increasing, and that has been documented in both the government tests that have been done, as well as the industry tests. And these are just some images of New York. Actually, okay, let me go to that one. Okay, great, no, that's perfect. So there was a 2018 multi-country study that was done and published that found RF levels increasing across countries. And I just wanted to point out that, for example, in Los Angeles, California, the level was 70 times what had been found in previous work done by the EPA and FCC. There were, the last publication actually by the US government was from a 1986 report where they had studies done the decade prior. And in that report, the TV and FM radio broadcast antennas were the dominant contributors to the RF exposures environmentally. But what the 2018 study found is that the mobile phone base station RF levels were now generally the dominant contributor to exposures in most outdoor areas. So just to show you what other countries are doing, this is France. They have their frequency agency. You can type in your address and you can get the levels that are in that area. You can go around a map and see what are the reports that have been done and the measurements. You can get the antenna power, the kind of antenna, all kinds of information, and that is accessible to all. Here's Switzerland, where they have a registry for antennas with all of this information available to the public and to anyone who wants to see it in terms of what the antennas are, et cetera. They even have a map that's like a heat map where they have the measurements and it's color-coded so you can see what the levels are based on the recordings that have been done. Now, some countries have 24/7 sensors set up that are constantly providing information that goes into these maps or online reports, and some do more spot checks and various measurement regimes that they then post that information online. So here's, for example, Greece. They have 500 fixed stations, 13 mobile stations. A lot of countries that don't have the fixed stations will then have their vehicles driving around doing measurements, you know, in a certain regime once a year, twice a year, or so forth. That's one of the largest actual registries. If you look at the map there with all the little triangles, you can see, you can click on them and actually see the sensor, read the real-time data that they have, and you know, hop around to various islands to see what's measured on the various islands. Although Australia and the United Kingdom, next slide, don't have continuous monitoring, they publicly post their spot measurements. And this is the Australian Communications and Media Authority. You can, again, type in your address and get documents as to what the levels are near you. Now in India, I guess I should say one thing, which is not all the countries follow the rules they have in the same way, and there's the oversight is all across the map. However, it is what is in the books, and as an example of what's happening in India, where you have actually illegal placements, you know, antennas hanging out of apartment windows that nobody knows how they got there, they're beginning a biannual measuring, and this is news from just last year, where they, actually this year, where they found 320 mobile towers exceeding EMF radiation limits. Now, you can go online to the website where they have all their reports uploaded, go by state, find the location, read the reports. But in the United States, of course, we don't have environmental mapping for non-ionizing electromagnetic fields. We have no registries of the antennas. We don't have health surveillance. We don't have funded activities by our agencies that have expertise in health and safety. And there's no oversight or compliance in place by the federal government regarding the reports that are out there. And there is now a high level of local government interest in RF measurements. And that's the apartment that I stayed in at the EMF medical conference after I went to San Francisco. And that's the view outside of my window. Here is a person who has a consumer RF meter measuring one of these gigantic 5G towers that are now up in New York City, where they have 2,000 of these proposed as the first rollout, and they have 5 tiers for antennas. So I'm just gonna, there's a lot to say, but I'm just gonna conclude with how the New Hampshire Commission report on 5G health and environment. They had 15 recommendations after reviewing this issue for a year, and some pertaining to measurement. Oh, it's the slide before that on the New Hampshire. I can just talk about it anyway.
We're
super.
Oh. Scott Blake Harris here, so
Okay.
I'm wondering, one, thank you for all that data. Two, we can take the slide you wish, we'll put it in the post-production.
Okay.
It'll be available to all the members. And three, I think what we're gonna need to do to compress this very vital information is, one, maybe we can drop through a couple of Jonathan's slides. A lot of you saw Jonathan present yesterday, his movie. Jonathan has some equipment, and he also has the nation's first RF deed holding that we're aware of, where there's PFD limits at the corner of the deed. And if we can maybe motor through that in a minute or two, and then I'll present some quick concluding slides, and in the post-production we'll add more of the detail.
Great. Thanks, Joe. It's good to be back. So yeah, I'll just talk briefly about the deed, which I'll make available to everyone if you're interested. Essentially, for someone like my wife who's electrically sensitive, it's a question like, do you invest your life savings in buying a house knowing that a cell tower application could come literally the next day? So that led to a lot of renting over the years, but we did finally buy a house a few years ago. And now the vision is to buy the barn in 17 acres, which we actually did do, across the street to create a theater, where electrically sensitive people would be accommodated, for example, including, of course, my wife. So, so this deed, if you scroll down a little bit, essentially we decided, 1 microwatt per meter squared at the property line is the limit. This, of course, we worked out in a series of conversations with the seller. And if you keep going down, and then but we also are sort of realizing that we're not going to be out there patrolling. It's and that this is really about trying to prevent emissions that are continuous and sort of 24/7, rather than the occasional person walking on the property line with a cell phone. We also wrote in there that we're agreed to assist the seller in lowering their, say for example, they sold to someone else who was not as, sort of accommodating as the current owner, that we would work with them, with actually buying them different products that are on the market now to help reduce their emissions at the property line. So if you keep going down. So for example, router Faraday cages, phone guard cases, adjustable coverage wireless routers with adjustable coverage areas, et cetera. Then we also volunteered to pay for any future opt-out fees for their, smart meters have not fully rolled out in Massachusetts, but that's kind of coming. And we're working to have a no-fee opt-out, but if that's not successful, essentially, so essentially we're just looking at ways to make it easy for them to comply with these limits. So moving on to the next slide. So this is an example, an electrosensitive engineer. If you just go back a little higher. So JRS Echo, this is an electrosensitive engineer from the Netherlands who came up with this, what was first a low radiation router, and now he actually offers a Wi-Fi on-demand router. In other words, there's no Wi-Fi unless the device is calling for it. So this, of course, is an energy savings as well as lowering exposure. And that sort of Wi-Fi on-demand is working well in homes around the world. It doesn't quite, this is not like, that model is not something that he's quite figured out how to just roll out in a very dense mesh network with a school, for example. But if you keep going down to the next slide, TechSafe Schools is one group that's working on lowering exposure to school children. And you essentially, they're providing instructions to the IT person at a particular school about ways to both reduce energy costs and reduce exposure to children. So for example, just turning the beacon signal down from, instead of pulsing every 1/10 of a second to pulsing every second, you have the same level of connectivity. Similarly, you can reduce power. If you've got a Wi-Fi access point in every classroom, their estimation is that you can actually, everything's set at 100%, of course, because that's just industry standard, but if you go down to 25%, you still have the same coverage in each classroom. If you keep going down, they also are talking about, of course, your engineers, that distance is a big deal when it comes to exposure. So, simply treating this thing, which is, of course, odorless and invisible, as the same way we treat light switches. We've all been trained, like, oh yeah, you leave the room, you turn off the light, you don't need the light, you turn off the light. Why not treat wireless the same way, especially with vulnerable populations like children? So these are a couple of innovations that are out there. And now let's, keep going. So here's some low-hanging fruit, a mix of policy and technical stuff. Putting small cells 50 feet or higher, setbacks of 1,500 feet for macro towers in rural communities. So in Europe, it's quite common, these echo mode cordless phones. You put it on the base station and the wireless turns off because you don't need it. Similar principle. There's a lot of people who, I mentioned yesterday a friend who's sick from, we're all working for fiber to the home as kind of a solution here, but at the same time, it's like people talk about true fiber, meaning fiber that goes all the way to the home and then gets to an ONT wired router. If it sort of goes back to consumer choice, if people even knew there was a choice, like, do I want a wireless router, or could I actually have a truly wired router that actually functions as a wired router, and then if I decide to add wireless to that, I can make that choice. At this point, people don't really even know the difference. I mean, it just gets installed, they get their cordless phone as part of it, and then if they do get sick or they do realize that this is not an exposure they want to have in their house, there's basically a whole lot of backfilling and endless hours, on the phone with providers trying to rectify a situation which could have been done right from the first time. So I'm sure all of you, I'd really like to leave time for questions. I'm sure all of you actually have a lot of even better ideas as you sort of think about how technically we can kind of both reduce exposure while ensuring connectivity. And I'm going to put that deed on this ptco.org/canaries, where anyone can just go and watch Canary and Goldmine on demand. And there's also a resource page, Canary resource page, which has all the panel discussions that have happened after Canary. And one that I'll just point out to you, we did it at the University of Albany School of Public Health with David Carpenter. And we had an engineering professor named Haney Elgala, who's been working on 5G and 6G networks in the academic realm. And he talked a lot about work on light-based communication and basically having a challenge getting his research to market about essentially switching from radiation to photons as a way of communicating wirelessly. So that's like a whole nother realm for you all to figure out, if you would, please. So questions?
Well, that's great. I think there's three things going on, and there's some immutable forces here in terms of time. So I think what we'll do is I'm going to maybe we can pull up I have some slides we can pull up they can sort of put together some of these thoughts. We can go to the next slide. So we're talking about complex environments. George walked through how you can comply with the very recent and very robust reporting or self-assessment and candor requirements with the FCC about if you have a Part 101 device and how do you comply, and that's quite detailed and quite linear in how to follow, and that's a public service, and I thank George and FWCC for working on that. That's a non-complex environment. What Theodora was showing pictures of, for example, somebody's holding a Amazon purchase meter in a very complex environment in Manhattan or San Francisco or wherever. We don't want people trying to self-assess with an Amazon meter because we know it's not meeting professional grade RF assessment. they're not using calibrated meters, they're not using PEs to run through it, and going through standard interference guideline assessment. So we can let the world go cowboy land and everyone can run around in zoning hearings and yell, but we might not get a lot of light from that heat. So in order to get light, professional grade measurements are what's really required. And this is the forum for professional grade measurement assessment when it comes to spectrum management. So obviously then what do you do with complex environments? What do you do when somebody is standing literally next to a 5G tower and they're holding a phone, which is the other end of a microwave link, and the guy next to you is holding a phone, or they're both in a subway and it's all refracting off? How do we measure that for compliance with the thermal standard? And how do we measure it for compliance with some of these bioactive standards? And because those are coming, those are in Europe, those are, as you saw from Theodora's slide, much more rigorous in terms of downstepping PFD and everything else. There are very quickly some other cases ongoing. There's a DC Superior Court case ongoing, and the methods and procedures and processes for the conclusion of that case are still TBD. That's a 20-year plus case, and we talked a little bit about that last year, but almost every industry player is involved. So we'll see what happens and if that manifests in a final ruling. There's also a similar case in federal court in Louisiana. And then, of course, we don't need to go into details, but because Theodora has already walked through it, but we have this human RF exposure standard case on remand, Environmental Health Trust et al. Versus the FCC, and the fact that they've been remanded and they're waiting for the FCC and the FDA, which was named in the cases, because the FCC has relied heavily on the FDA for what is the human RF exposure standard. We don't need to go into a lot of details because we don't really have time, but there's a whole series of FDA petitions and other activities underway, and this is a very active environment. And on top of that, as mentioned yesterday in the Satellite Mega Constellation Department, there we've gone from 8,000 satellites deployed from Sputnik until 2021, of which only arguably a little under 3,000 are actually still active, to licensees now getting 40,000 satellites at a clip, plus blanket licenses for 1 million base stations. And all these satellite mega constellations, which are much, much closer. Sputnik was around 30,000 kilometers away. Now we're talking 450 kilometers, a much tighter web around the Earth, and they all want to connect to your phone. Ultimately, that's a lot of their plans. And they also interact with the 5G networks and other terrestrial networks. And what does all that mean for this issue? Complex environment. And so I count on a crying need for spectrum managers to measure this responsibly with calibrated equipment, with PEs who know what they're doing, and replicably so. And that's, I think, an added growth sector for the NSMA and its constituencies. So stay tuned on that. With that, I think I'm going to stop with the slides. There's a lot more here we could go into, but we don't have time because we want to get you guys some lunch, and Scott Blake Harris will be speaking at the luncheon. But we can take a question or two if anyone has a question or two on this subject.
I guess my question is to Theodora. You were mentioning how like the standards in the US are based on sort of biological effects. And if I remember correctly, they kind of figured out what sort of exposure rate, power flux density of microwaves is required to sort of raise your body temperature by 1 degree, and then said, okay, we'll put a factor of 10 in there. And that's more or less how they kind of came up with the 1 milliwatt per square centimeter, or your 10 watts per square meter. But then there's other countries which are much lower limits now. Is that just based on more safety factors, or there's more research that's been done since then that show there are biological effects to even lower power flux densities than were previously known?
Well, they have set, so the countries that use the precautionary principle basically did a factor lower than ICNIRP limits just to be more protective. And the Russia and China, actually, their scientists themselves have done many studies that have identified various biological effects, and they actually have different formulas as to how they came up with their limits. And there are voices saying these limits are not protective even at 1/10 and lower. But they acknowledge, like there was a presentation by China to the ITU where they talk about all the studies that have been done and how they acknowledge these biological effects, so therefore we're setting it at this limit. And of course, for different frequency ranges, they have a different limit. And also the countries measure the exposure differently depending on the country. But they have their own scientists in China and in Russia that have been working for decades, actually, on this issue.
Thank you.
And one coda to that, we did do a study in Washington, D.C. using professional grade calibrated equipment and Ritsu and Rode and systems like that. We tied it to, we used Tom Brinkotter and others, and we used wood pedestals and things that are not reflective, and you don't get any troposcopic scatter or anything else off of any other environments. And this was a rooftop where there were 5G base stations. There was no signage. There was a chain link fence where the tables where the base stations were. There was a chain link fence, and there were pool chairs lined up. And inside the sun deck area, if you count crest factor, the FCC thermal standard was exceeded by 243%. And that did not account for if people were operating their phones in those chairs. And of course, it didn't account for the SAR values, which are phone-based versus base station-based. The OMB, or the Circular 65 does talk that, licensees who contribute 5% or more to the complex environment, and if there's an overage, they have a duty to mitigate. And so what Ira Kelch was talking with OAT, if we apprehend there's something going on, we do need to report it as an industry. So what does industry do without guidelines? It goes in 100 million directions, or it freezes. So this kind of brings us back to here in the US, we have ready, and this, by the way, this study I just referenced was filed with the FDA as part of the remand, and there's an FDA petition. So what we're needing to do here is cut the wheat from the chaff and figure out very quickly how to do RF measurements in complex environments, replicably so, understand what those measurements are, and then come up with guidelines on how to mitigate. Some of the devices that Jonathan's talking about, some of the leadership we're seeing from other countries in terms of reducing RF exposure because they're looking at biological impacts in addition to the thermal impacts, may be a formula for us to follow. But I think NSMA has historically led the way with looking at all this and coming up with the guidelines, and maybe through our working group 3 or some other working group, we could bring to the forefront how to really analyze this. I think is probably where we're at.